Hello, we are Team 6, and today we will present our project titled Alternative Energy Sources for Automobiles, a comparative chemical analysis. As we all know, most vehicles today still rely on gasoline. However, gasoline is becoming more expensive, less available, and most importantly, is one of the main sources of environmental pollution. Because of this, car manufacturers are now exploring cleaner and more sustainable energy alternatives. In our project, we focus on three major alternatives: galvanic cells, hydrogen fuel cells, and solar energy systems. We studied how each of these technologies works, how efficient they are, and how much they pollute, and whenever they could realistically be used in vehicles. Finally, we tested a small electric car powered by one of these technologies and used that data to better understand which energy source might be the best.
Now I will explain chemical concepts that were applied to a problem situation: galvanic cells, hydrogen fuel cells, and photovoltaic cells. Each system operates through distinct processes, contributing to different environmental and technological implications. Galvanic cells transform chemical energy into electrical energy through spontaneous redox reactions in the zinc-copper system. Zinc at anode undergoes oxidation, while copper ions at the cathode undergo reduction, generating electron flow through an external circuit. The diagram illustrates this process with directional electron flow and a south bridge maintaining charge balance. Hydrogen fuel cells, on the other hand, generate electricity by electrochemical reactions between hydrogen and oxygen. Hydrogen enters the anode, splitting into protons and electrons. The electrons travel through an external circuit, producing electrical energy, while protons migrate through the proton exchange membrane (PERM) to the cathode, where they react with oxygen to form water. The diagram highlights these pathways. Photovoltaic cells generate electricity by leveraging the photoelectric effect in semiconductors. Sunlight excites electrons in silicon, creating an electrical current without a chemical reaction. The diagram visualizes electron movement initiated by photon absorption.
Performance analysis. Well, first we have a galvanic cell with a 90% of energy efficiency. The operational cost is low and the pollution during its low too. The hydrogen fall it 40-60 of energy percent efficiency, has a high operation cost and none of pollution. For the last one is photovoltaic with a 50-20 approximately of energy efficiency, low cost and no pollution. Environment impact of energy sources. Galvanic cell, well, this one has heavy metal contamination, resource extraction and waste management challenges. The hydrogen fuel cells, the extraction of hydrogen produced from fossil fuels, and water consumption. For the last, photovoltaic manufacturing process and the end of life disposal.
Analysis and justification. Which method is the most efficient in energy production? First, hydrogen fuel cells are the most efficient in direct energy conversion, especially under cogeneration systems. And which is the most cost effective in operation? The solar cells, due to zero fuel cost and low maintenance over time. And which is the least polluting in operation? Both solar and fuel cells operate without direct emissions. Fuel cells only release water vapor, and which is polluting in manufacturing? Fuel cells. Their production impact depends on the hydrogen source. Green hydrogen that it's produced via electrolysis using renewable energy, and they has a lower environmental footprint compared to hydrogen derived from fossil fuels. On the other hand, solar and galvanic systems involve extensive sources extraction, and processing.
After analyzing each system and conducting a real test where our experimental car traveled at 420 centimeters, we reached the following conclusions. Hydrogen fuel cells were the most efficient overall, offering a good balance between performance and sustainability. Solar cells are the cleanest option, but they are still limited by their low energy output and dependence on the sunlight. Galvanic cells are not practical for long-term propulsion, but they were effective in powering our small-scale vehicle. This analysis helped us understand that transitioning to renewable energy is essential to reduce pollution and break our dependency on fossil fuels. As future professionals, we believe it's our responsibility to explore innovative and sustainable solutions that contribute to a cleaner future for transportation.